So we start sort of at the end. We approach societal challenges and business challenges, and we try to map that to use cases and actual applications. We do this for science, for government, for business, and also for society at large. Most of these areas where applications are currently being explored, you must have seen before. There's some in biotech, life sciences, pharma. Again, could I see sort of where you're from? Anyone in these areas? Not really. Financials, they're exploring quantum applications for optimized portfolio management, not just to speed up, I would say also for reducing risk. Then there's energy. Anyone in the energy industry? Very good. They're exploring quantum computing for, say, battery management systems, for optimization problems in decentralized grids. More and more, as you see the transition emerge in that domain, quantum applications are being actively explored. And then finally, there's a large class of what I would call quantum-enhanced machine learning and optimized algorithms. Then who are we? Oh, sorry, this is not going well. So the Quantum Application Lab is an open R&D collaboration. It's been founded by 6 partners. It's CWI, it stands for the National Institute for Computer Science and Mathematics. The eScience Center, it's very much focused on research software development. Quantum Inspire, which is by QTech, a consortium by TU Delft and TNO. SURF, they run the HPC cluster, so high performance computing. TNO, we typically do applied science out of the Netherlands, but very much also in Europe and abroad. And then lastly, University of Amsterdam. I noticed the University of Amsterdam has been established in 1632, so well over a decade before the Declaration of Independence here in the United States. So as much as the Quantum Application Lab may be considered a startup, the founding entities are clearly not. And then we also work with technology partners, some of them here. One thing to mention is that in our collaboration, it's not necessarily the more the merrier. We're not a network organization, so we should take as much as work on us as we can handle. So we try to include all leading qubit technologies, but not necessarily anyone. And you can guess probably what group of stakeholder is missing here. It's clients, of course. The Quantum Application Lab is very much focused on working with clients. And for those companies, we want to create economic benefits. So we typically don't explain what quantum is, but what it does to their business. We have a variety of capabilities, competences, and skills gathered in this collaboration, ranging from scientists and researchers to architects, engineers, code developers, consultants, and perhaps even some lobbyists. But ultimately all gathered around in what you could call, perhaps a bit cheeky, but quantum application development as a service. The acronym would have been QADASH, which sounds much better than Quantum Application Lab or CAL, but either way, we have a large group of skills centered around the question of end users, I would say, clients. We call them participants. And there's not many figures in my presentation, but here all the way down, you would see that we're looking to create and deliver a multiplier of 3 to 8 towards participants. And I'll be happy to explain much more if interested after this talk. So what we do, I'll quickly raise 3 of those benefits. It's evidence decision making on quantum computing applications. Again, not necessarily focusing just on one particular type of hardware or algorithms, but really how to put them to practice in what we call early stage pre-competitive R&D collaborations. Finally, we tend to focus on solutions. Again, it could very well be that being so early in quantum, we find that actually we have solutions that run classically much better, and we should, well, sort of see those as quantum-inspired type of engagements that nevertheless yield impressive results. Not exponential perhaps, but very much dramatic or incremental. Some ways to engage, perhaps for those of you who think this collaboration could be of interest. Sort of small, medium, large, depending on what region you're from. You're reading this from left to right or right to left, but typically getting this off the ground is not a small feature. It's consistent with the BCG, so the Business Consultancy Group keynote from this morning. He said there's a sort of minimum threshold. He quantified this in terms of dollar amounts. Say anything below $1 million is probably not resonating well. I find that sort of threshold not too important, but I think it is indeed a significant approach from a company that investing time, money, and resources in getting that first step in place. And that's why we call this a first step, strategic exploration and discovery, and we have a few of those running already. Then you're sort of promoted to use case selection and roadmap design. Again, something that doesn't represent an actual application just yet, but it's very much leading towards that final step. And although we may not demonstrate quantum advantage yet, there is some quantum value in there, so clients do appreciate those preparing actions. Finally, of course, and you'll see it down here, duration is then slightly longer. We probably need more resources, but finally we also do proof of concept demonstrators. And we do this for quite a few industries already. This is a work in progress. You'll see some automotive companies here, some energy companies, and as much as the focus from the purpose is similar, so simulation, optimization, machine learning, I find that the topics couldn't be more diverse. I'll just mention one, and that is in what here is called breeding value estimation, BVE, in the agri-food sector. Then I heard back from the team that for example, pigs, like in you could approach this from the food production angle, but they do a lot of tail biting. So it's one of the behavioral feeds that is resulting from keeping a lot of animals, in this case pigs, obviously, in a condensed area. And I know nothing about this particular domain, but I do feel that if we are able to optimize this process, we are able to not only help an industry in getting rid of all in getting rid of some of the problems they face. It's also an opportunity to demonstrate the value of quantum applications by, for example, reducing problems that are now the result of actually not the right computations or the limitations in model complexity. We would now just focus on, say, how is the maximized output in terms of meat production, and we would sort of ignore the downside. And I'm hoping you get from this example that it's not just in the agri-food industry, but it can equally be done in automotive when it's about energy and battery management systems. I have a few early results to present. Most of the work we do is open source, open science, but not just all. This may not be trivial. It's from residual statics estimation in the oil and gas industry. Again, an area I know nothing of. There's oil and gas companies that have hundreds of people working on subsurface imaging. whenever they have an oil rig and they need to put it somewhere, that's investments of billions of dollars each year. And here we found that on this early stage with quantum annealing, there's already a 10% better performance in stack power compared to what you could do classically today. Another example is from the finance industry. Again, it's quantum annealing, so some may argue it's not the fault-tolerant quantum computer and the true quantum backends that we have deployed. We are running those projects, but like I said, it's too early to report on those. This is just as an illustration that we've started working on real-life problems, real-life use cases, and find that either we are able to map whatever is out there already commercially, or we have something that will scale once the hardware will improve. We expect the performance to equally proceed and perform better over time. Or we find that model complexity is already enlarged. Here we demonstrated that we can run this on an annealer better than we can do classically. And of course, this is with all the disclaimers that we've only started and this is an annealer and not a real quantum backend. And then finally, one example, also early stage, which is about capacity management for decentralized energy grids. It's in the industry being referred to as the N-1 problem, but of course you want to optimize the efficiency of your grid in the best possible way, something for which you may need a quantum computer in future, but with heuristics and simulators, annealers, there's already quite a bit you can do today, either in terms of compute power or in terms of model complexity. So that would bring me to sort of the end of the talk, which is very much about being at the forefront of quantum technology, and then within that larger class, the subset that is representing quantum computing, and then actually making this work, which is mostly about physics and engineering, but it's also about people and guiding groups along that path towards demonstrating value first and then advantage later, hopefully. I'll be happy, so I didn't even need the signs for running over time, but I would be happy to respond to any questions or perhaps areas that I forgot to mention from the audience.
We do have time for questions, so yes.
Hi, thanks for your presentation. I was wondering, I did see in one of your earlier slides, there you have some technology partners, and there were some famous names with AWS, Microsoft, IBM, I think. Could you tell a little bit more about what their role is in what you are doing?
Yes. I know we can't be hardware agnostic at this stage. That's something that clients perhaps would say, like in the vendor lock-in in cloud computing they experience now. It's reasonable to assume that going forward, they don't necessarily care about the providers, but much more about functionality. I have to say that IBM has been leading in this. We ever since they created a long-term partnership in Germany in 2018, we have been engaged. I know IBM in the Netherlands has been actively investing in R&D collaboration for over 100 years. So we're very much exploring how to utilize their quantum backends, their simulators, in a way that is useful for end users. Again, not just pushing one particular qubit technology, but very much starting at the end. What can we use the technology for, and then reverse engineer. With the others, I have to say, we're less far in our conversations. We needed a lot of time to get this collaboration in place. But now we're ready. We can take this as we go and include more and more qubit technologies. We include them in use cases as to demonstrate the value of those qubit technologies for particular use cases. Again, for simulation, it could be that Xanadu's PennyLane is yielding already interesting results. I'm also very open about being agnostic to those companies. As much as I would love to do their pre-sales, I have to be transparent. So the Quantum Application Lab is agnostic, but is using leading qubit technologies to include in use case-driven application development. Is that sort of answering your question?
Thank you. Yeah.
Okay.
Okay, I think we have time maybe for one more question, if there are any more from the audience.
Perhaps one question then, add on to that question. If there's any technology partners in quantum computing, but optical hardware could be equally important, that ultimately is trying to extrapolate that Moore's law, that we would say in future we need more compute power, and we want to explore even other capabilities that quantum computers in future may have, then I'm also very much, my question to the audience would be, so if there's any other technology partners that you think could be interested here, I'll be more than happy to consider the collaboration there. So this is really hoping, this is just an as-is reflection of where we are now, but hopefully it will grow over time.